turn back on the feet. Right. It's very simple. I'll leave it here, then you can later on see after the video. So the whole idea is that I put a glare on that. Okay? So the whole point of it is that you need to supply a lot of air to this burning biomass. Because you know, the air supply creates good combustion. And when you get good combustion, the temperature rises. So you want as high a temperature as possible. So this machine, what is called Varuna Yantra, it requires about 10 assorted pieces of these GI pipes and you know a drum and a few this, and can be costly under about 3,000 rupees, including the blower. The blower is the most expensive. It costs about 700 rupees for one of them. Now I have considered of other. You see, I don't know whether any of you have read, in Saka there was a headline news on the 11th of May, which they had said Varuna Yantra Vapra, and it was published all over Maharashtra. I have seen more than 4,000 phone calls from all over the villages, all over Maharashtra, because people want to do it, because people are desperate. In the villages, particularly, people are more desperate. Urban people haven't gone so desperate because they get from the Pune municipal corporation water, but I tell you, you will get desperate. Because right now only 4%, the dams have only 4% water right now. So if it doesn't rain well, and if you cannot make rain this year, you are going to have problems in the urban areas as well. And if it doesn't rain in the urban areas, rural people will migrate to the urban areas where there is water available. So you will have a huge amount of influx of the rural people coming into the urban area. So it is not a village's problem. Rainmaking is, unfortunately, people think that it is a farmer's problem, but it is not. It is a whole Indian national economy problem. If it doesn't rain, if there is agricultural downfall, the consumer goods will not sell. TVs, mobiles, all kinds of things. Most of the market right now is in the rural areas. It will not bear. So it will have an impact on the industry in the urban areas, and people will lose their jobs, and so on and so forth. So these are absolutely connected with each other, which people don't see. So when I got so many phone calls, about 4,000, I said there is no way I can move these tankees all over Maharashtra. So I come out with a 6th version, where you can build it by building a 4 feet by 4 feet by 4 feet brick structure with a wall thickness about 4 inches. And then the brick structure has ventilation holes like that from below, like here. And then you put a pipe again. So it requires about 400 bricks, 1 bag of cement, couple of bags of sand, and it takes about 1 day of labor to build such a structure. It will again cost about 3,000 to 3,500 rupees, typically the price of building this. I'm thinking about making a portable one, which will be made of mild steel sheets. Instead of this round tanky, it will have mild steel sheets, and they can be just screwed and nut and bolted together. That is basically the idea. Instead of doing the welding. See, there is a group of people in Latur, and they have a women's organization, so they want to be able to build these things on, on their own. So this is another thing which I am trying to do. So this is the Varuna Yantra which you just saw, and this is how the flames come, and these are the basically. So my inventiveness is in 2 things. One is throwing salt onto the wood. Nobody has done it so far. People have tried to do grounder seeding using silver iodide in Europe, which has to be dissolved in ethane kind of chemical, and then they make what you call gas-based seeding machines by which you can do cloud seeding. But that is all cold cloud seeding. Wall cloud seeding from the ground, nobody has done so far. I think all over the world actually, as far as I know. I talked to Professor Shivaji Rao and I did a lot of research on that. So what is the physical chemistry? What is happening actually in the process? That is very important. All you are engineers, and I'm sure some point or the other you have studied chemistry and physics, maybe in first year, but most of it. I used to get Persistent, some years back. I was an advisor for training, basically 3 or 4 years back. And I used to train the fresh engineers, and I would ask them questions about something which they learned. So they said, we learned that in first year engineering. Why are you asking us now? So I think what has happened with all of us, that whatever knowledge we acquire in the early part, it is all gone and rusted. So let me just give you a quick refresher thing on chemistry. That when you pour any wood, it is typically C6H12O6. So when you burn that, you get CO2 and H2O. So actually water vapor gets created when you burn any biomass. When you burn this, actually water vapor is going to get created locally. Now with this design and the airflow, I am able to achieve temperatures about 1200 degrees centigrade internally. And the instantaneous temperatures are much larger. That is, this is an average temperature. So at the time of when something burns, it burns in a, these are all quantum mechanical phenomena. If you want to look at it, you might just describe it in the classical physics way. But lots of, electrons are exchanging, spaces with each other, bonds are breaking up, and all these are basically quantum mechanical phenomena. So when they happen in picosecond type of durations. So in these processes, instantaneous temperatures are very high. So the four possible processes that are happening when I throw salt onto this, actually a lot more study has to be done. There is hardly any study anybody has done of you throw salt on a burning fire, what happens. So I talked to Dr. Mashaikar, who has taken a great deal of interest in this project, and we are trying to get help of some of the scientists from different parts of the chemical laboratories to see if we can go more deeply. So the four possible processes which I have identified are the vaporization of salt, because the sodium chloride, as I said, the boiling 800 point is the melting point and boiling point is 1413. So if you get a 1200 degrees temperature internally, it is in liquid stage and so it vaporizes, just like water vaporizes over the sea. The second thing is saline water is also getting vaporized, because actually we are creating saline water on the surface of the combusting material. When you throw salt, and actually I am suggesting now that instead of salt we can even put saline water onto the fire. The third thing is, as I said, plasma is getting created at a nanoscale or a pico duration plasma at that very low level, and that's doing also a whole lot of things. And the fourth thing is the bubbles are bursting. When the bubbles are getting formed, they are bursting. So when a bubble bursts, it picks out material and throws it to the air. So this is basically the physical chemistry of why this could be working. Now the question is, you are doing something at ground and the clouds are at 1 kilometer height. Now how is it that this salt being thrown here will go up to the clouds at that height with this much of fire? It's a question which any reasonable person would have in mind. So typically what happens is, there is what is called a boundary layer in the atmosphere. See, the clouds which you see floating, they are floating at about 1 kilometer and above. This is called the troposphere, and they are freely floating in that space in the troposphere. Now what happens is, between the troposphere, that is the free atmosphere here, and the earth which is here, there is what is called a boundary layer. And the boundary layer is because earth is different material and air is different material, so any viscous fluids and air is a viscous fluid. So when two viscous fluids and earth is rotating around itself and wind is happening, so in that whole process, there is a whole turbulence being created on the earth's surface. So you have what is called a boundary layer. So there is a small boundary layer about 100 and 150 meters. This boundary layer basically consists of the breeze that you see in the afternoon, morning, early morning, because of the uneven heating of the earth by the sun. See, when there is a shade, like the trees, it will not heat so much, and if there is a tar road, it will heat a lot more. So there, the hot air will go up, and the cool air from the trees will come to take its place. So you will get a breeze. So all the breeze that you see on the ground is happening in this what is called the surface layer. That is about 100 to 150 meters in thickness. Beyond that, there is what is called a mixed layer. Here what happens is, all these unevenness phenomena and the air currents, they all get mixed. And you get a uniform mixture of air. And thermals are going up here. What are called thermals? These are hot currents of air, because all the small hot next slide will explain that a little better. These are called thermals. Basically, when you see earth getting heated, what happens is hot air starts going like this. These are like the roots of these hot air currents. And in the mixed layer, they merge together. And you get about half a kilometer or 1 kilometer wide thermals, these are called. If you see the gliders go on the thermals. You see, they have no power, but they float on the thermals. Or if you see those people who do paragliding, they also float on the thermals. Or there are some birds which fly without any movement of the wings. They are also floating on these thermals which are taking them upward. So these are typically thermals. It's a very standard atmospheric phenomenon. It has nothing to do with my Baru Yantra, but I am just using that. What I am doing is, in this process of fire, I am creating surface thermals locally, effectively. It's like having sunlight. Actually, this works to be, if you see the amount of heat that is generated, it works to about 800 square meters of heat is being generated in this local space. If you take the sunlight, it gives about 3000 watts per meter. That is the heat energy that you will see from the sun. So it is doing a lot of energy. So what I'm doing is